There is an industry that moves $95 billion every year, but most people have never seen its final product working. It has no glamorous stores. It doesn't appear in television commercials. It has no celebrities promoting it. Yet without it, the modern world would simply cease to exist. We're talking about printed circuit boards, the invisible heart of absolutely everything you consider technology. Every time you touch your phone, start your car, use an ATM, or simply turn on the light in your house, you're depending on these green boards filled with copper pathways and electronic components. They're so omnipresent, they've become invisible, so essential that nobody stops to think about them. But behind this invisibility exists a colossal market that rivals entire industries of developed countries. $95 billion is not just an impressive number. It's more than the gross domestic product of nations like Kenya, Bolivia, or Paraguay. It's enough money to buy all the shares of tech giants or fund complete space programs. And all of this revolves around components that most people don't even know exist inside their devices. The printed circuit board industry operates in the shadows of the global economy, but its influence is absolute. From the smartphone in your pocket to the air traffic control systems that keep millions of flights safe, everything depends on these structures of fiberglass and copper. Without them, hospitals couldn't operate medical equipment, banks couldn't process transactions, and global communication would simply collapse. Welcome to Factory Made, where today we're going to discover how an invisible industry built an empire of almost $100 billion annually. Get ready to understand why these seemingly simple boards are, in reality, the economic and technological backbone of the 21st century. What you're about to discover will forever change the way you see the technology around you. Imagine for a moment that all the printed circuit boards in the world stopped working simultaneously. Within seconds, civilization as you know it would begin to crumble. Hospitals would lose access to heart monitors, respirators, and diagnostic equipment. Global communication systems would go silent. Electrical grids would collapse without their automated control systems. This apocalyptic scenario is not science fiction. It's a demonstration of how deeply we depend on this technology. Every major economic sector on the planet has its operation tied to these boards. The automotive industry, which moves trillions of dollars globally, uses between 50 and 100 printed circuit boards in each modern vehicle. Without them, automobiles would return to being purely mechanical machines from the 1950s. The telecommunications sector, valued at more than $1 trillion, is completely dependent on these boards. Every cell tower, every router, every communications satellite contains multiple printed circuit boards working together. The infrastructure that allows you to make a video call with someone on the other side of the world exists thanks to millions of these boards operating without rest. The medical industry represents one of the most lucrative markets for high-specification printed circuit boards. A single MRI machine can contain dozens of specialized boards, each costing thousands of dollars. Pacemakers, defibrillators, and continuous monitoring systems depend on miniaturized boards of extreme reliability. Here, the value is not just in the product, but in the human life it protects. Even sectors that seem far from technology depend completely on these boards. Modern agriculture uses tractors with GPS systems and automated control. The food industry depends on electronically controlled refrigeration and processing systems. Entertainment, from video game consoles to professional sound systems, wouldn't exist without printed circuit boards. We're talking about a technology that literally sustains the modern global economy. $95 billion annually doesn't materialize from nothing. This number represents an extraordinarily complex value chain that begins with basic raw materials and ends in devices that cost thousands of dollars. Understanding how this money is distributed is to understand one of the most fascinating economic flows of modern capitalism. The market divides into segments with radically different profit margins. Simple single-layer boards used in basic consumer products can cost cents per dollar and represent the largest volume in units. However, high-density multi-layer boards used in medical or aerospace equipment can cost hundreds or even thousands of dollars each. This is where most of the monetary value is concentrated. The Asia-Pacific region dominates production with approximately 60% of the global market, which represents about $57 billion in that region alone. Mainland China is the absolute epicenter, producing more printed circuit boards than the rest of the world combined. But value is not distributed uniformly. While China dominates in volume and medium-priced boards, the United States and Europe capture the very high value-added segments. Profit margins vary dramatically depending on complexity. A standard board manufacturer can operate with margins of 5 to 10%, depending on massive economies of scale to be profitable. In contrast, manufacturers specializing in boards for military, medical, or aerospace applications can have margins of 30 to 50%, justified by rigorous certifications and extreme quality requirements. The projected market growth is equally impressive. Analysts estimate the industry will reach between $120 and $140 billion in the next 5 to 7 years. This growth is driven by the explosion of connected devices, electric vehicles, fifth-generation infrastructure, and the increasing complexity of all electronic devices. We're not talking about a stagnant industry, but a sector in accelerated expansion. The versatility of printed circuit boards is what makes this industry so valuable. There is virtually no modern electronic device that doesn't depend on them. This universality creates an extraordinary economic multiplier effect. Each new category of technological product represents a new multi-billion-dollar market for the board industry. Your smartphone contains between 8 and 12 different printed circuit boards. The main board, where the processor resides, is a masterpiece of miniaturization with more than 10 layers of interconnected circuits. There are separate boards for the camera, for battery management, for wireless connectivity. Each represents a specialized niche with its own technical and economic challenges. Multiply this by the more than 1 billion smartphones produced annually, and you begin to understand the scale. The automotive industry is experiencing a revolution that's skyrocketing the demand for printed circuit boards. A modern electric vehicle can contain more than 100 different boards, from battery management systems to automated driving assistance. The battery management system alone can require dozens of specialized boards capable of handling very high currents and extreme thermal conditions. This is a market that's just beginning its expansion. Data centers, which sustain the global digital economy, are massive consumers of high-performance printed circuit boards. Each server contains multiple large motherboards, specialized network cards, storage controllers. A single large-scale data center can contain tens of thousands of servers, each with multiple boards. We're talking about millions of boards just in the infrastructure that allows you to use social media or watch videos online. The aerospace and defense sector represents the highest value segment per unit. A communications satellite can contain printed circuit boards that cost tens of thousands of dollars each, designed to operate in the vacuum of space for decades without maintenance. Avionics systems in commercial and military aircraft use boards with certifications so rigorous that the qualification process can take years. Here, price is not the limiting factor. Absolute reliability is. Behind the $95 billion exists a concentration of economic power that few know about. A handful of corporations controls most of the global market, operating massive factories that produce millions of boards monthly. These invisible giants have more influence over the global technology economy than many famous tech companies. The top 10 printed circuit board manufacturing companies control approximately 40% of the global market. This means that about $38 billion flows through just 10 organizations. Companies like Nippon Mectron, Unimicron Technology, and Tripod Technology are names unknown to the general public. But they are absolutely critical to giants like Apple, Samsung, and Tesla. The bargaining power of these manufacturers is immense. When a major manufacturer faces production problems or decides to increase prices, the domino effect is felt throughout the global supply chain. We've seen this during recent supply chain disruptions, where the scarcity of printed circuit boards delayed the production of automobiles, appliances, and consumer electronics, causing losses of billions of dollars. Vertical integration is a key strategy in this industry. Some manufacturers control everything from copper laminate production to final component assembly on boards. This integration allows higher margins and greater quality control, but also creates enormous barriers to entry. Establishing a competitive printed circuit board factory can require investments of hundreds of millions of dollars in specialized equipment. Competition in this sector is not based only on price, but on technological capability. Manufacturers who master extreme miniaturization techniques, high-frequency boards, or special materials capture the most lucrative segments. Research and development in this industry represents billions of dollars annually, with companies competing to reduce the thickness of copper traces, increase the number of layers, and improve thermal dissipation. Innovation here is as intense as in any high-tech sector. The flow of money in the printed circuit board industry is a cascade that begins with basic raw materials and ends in consumer products worth thousands of dollars. Understanding this value chain is to understand how economic value multiplies at each stage of the process. It all starts with copper, fiberglass, and epoxy resins. The copper laminate market for printed circuit boards alone moves several billion dollars annually. Specialized suppliers produce copper sheets of microscopic thickness adhered to fiberglass substrates. This base material, although it seems simple, requires extreme quality control and represents the first layer of added value. Board manufacturers take these materials and transform them into products worth 10 to 50 times more. A complex printed circuit board can go through more than 20 different processes: chemical etching, laser drilling, metal deposition, solder mask application, screen printing. Each process adds value and complexity. A board that started worth $5 in materials can sell for $50 to $200 after processing. But the chain doesn't end there. Electronic assembly companies take these bare boards and populate them with components: processors, memories, capacitors, resistors. This assembly process can double or triple the value again. A board that cost $100 can become a module worth $300 or $500 once fully assembled and tested. Finally, these assembled boards are integrated into final products. A smartphone that contains boards and components that cost perhaps $100 in total sells for $800 or $1,000. Medical equipment with boards that cost $2,000 can sell for $50,000. This multiplication of value at each stage is what makes the electronic supply chain one of the most lucrative in modern capitalism. The margin at each stage varies, but the total sum is impressive. If we follow $1 that enters as raw materials, that dollar can become $5 in board manufacturing, then $15 after assembly, and finally $50 to $100 in the final product to the consumer. This is the economic magic of the electronics industry, and printed circuit boards are at the absolute heart of this value creation chain. The global dependence on printed circuit boards becomes painfully evident when the supply chain is disrupted. Recent events have demonstrated that this invisible industry has the power to paralyze entire economic sectors, causing losses measured in tens of billions of dollars. During recent global supply chain disruptions, the scarcity of printed circuit boards forced automobile manufacturers to halt complete production lines, not for lack of engines, steel, or tires, but for the absence of boards that control electronic systems. Automotive companies lost billions of dollars in revenue because they couldn't obtain components that represent less than 1% of a vehicle's total cost. This is the paradox of the modern world. The smallest components have the greatest disruptive power. The geographical concentration of production creates systemic vulnerabilities. With more than 60% of production concentrated in East Asia, any event affecting this region has immediate global repercussions. Natural disasters, geopolitical tensions, or even logistical problems can create bottlenecks that affect industries on all continents. This fragility has led Western governments to invest billions in incentives to diversify production. The cost of scarcity is not just financial, it's strategic. Countries that depend completely on printed circuit board imports find themselves in a position of technological and economic vulnerability. This has led to massive government initiatives to develop local production capacity. The United States, Europe, and other economic blocs are investing tens of billions of dollars in subsidies and development programs to reduce their dependence on suppliers concentrated in few regions. The industry has responded with diversification and redundancy strategies. Large electronics manufacturers now maintain multiple printed circuit board suppliers in different geographical regions. Some are investing directly in their own factories to ensure critical supply. This reconfiguration of the supply chain is creating new investment and development opportunities, but also increasing costs. The price of resilience is measured in billions of additional dollars in the global cost structure. Not all printed circuit boards are equal, and differences in complexity create extraordinary value stratifications. At the lower end of the spectrum, simple single-layer boards can cost cents. At the upper end, specialized boards can cost thousands of dollars each. This price variation of 1,000 times or more is unique in modern manufacturing. Single or double-layer boards, used in basic consumer products like electronic toys or simple appliances, compete primarily on price. Margins are thin, competition is fierce, and success depends on massive volume and extreme efficiency. Here, fractions of a cent per unit can mean the difference between profit and loss. This segment represents the largest volume in units, but a smaller fraction of the market's total value. Medium-density multi-layer boards with 4 to 8 layers represent the heart of the market in terms of value. These boards are used in computers, smartphones, network equipment, and advanced consumer electronics. Here, the balance between cost and capability is critical. Manufacturers who dominate this segment operate with moderate margins but enormous volumes, generating billions in annual revenue. At the upper end are high-density boards with 10, 20, or even more than 30 layers. These engineering marvels contain thousands of microscopic connections, blind and buried vias, and tolerances measured in microns. They're used in high-performance servers, advanced telecommunications equipment, critical medical systems, and aerospace applications. A single board can require weeks of production and go through hundreds of quality control steps. Specialized boards for extreme applications represent the pinnacle of value. Boards designed to operate in space must resist radiation, vacuum, and extreme thermal changes. Boards for implantable medical equipment must be biocompatible and absolutely reliable for decades. Boards for defense systems require rigorous security certifications and complete traceability of every material used. In these niches, price is not the determining factor. Technical capability and absolute reliability are. This is where the highest margins are generated and where technological innovation translates directly into economic value. The $95 billion market is not a ceiling, it's a starting point. Multiple technological trends are converging to drive explosive growth in demand for printed circuit boards. Each of these trends represents billions of dollars in new opportunities. The electric vehicle revolution is just beginning. Each electric vehicle requires significantly more printed circuit boards than a traditional combustion vehicle. Battery management systems, power inverters, charging systems, and automated driving assistance are all electronics intensive. With projections of tens of millions of electric vehicles being produced annually in the coming years, this sector alone could add $10 to $15 billion to the board market. Fifth-generation infrastructure is creating massive demand for high-performance boards. Each fifth-generation base station requires specialized boards capable of handling very high frequencies and complex signal processing. With millions of base stations being deployed globally and each containing multiple expensive boards, this market represents several billion dollars in opportunities. Sixth generation, already in development, promises to be even more technologically demanding. The Internet of Things is exponentially multiplying the number of connected devices. Projections suggest there will be more than 50 billion connected devices in operation in the coming years. Every smart sensor, every connected home device, every industrial monitor requires at least one printed circuit board. Although many of these boards are simple and cheap, the absolute volume is so massive it represents a market of several billion dollars. Edge computing and artificial intelligence are driving demand for extremely complex boards. Artificial intelligence processors require boards with exceptional thermal capabilities and unprecedented interconnection densities. Data centers specialized in artificial intelligence are being built with investments of billions of dollars, and each requires state-of-the-art printed circuit boards. This is a market where technical complexity translates directly into premium prices and high margins. Printed circuit boards have become a strategic asset in global geopolitical competition. Control of this seemingly mundane technology is now considered a matter of national security by major economic powers. Billions of dollars in government subsidies are being deployed to reshape the global production map. The concentration of production in East Asia, particularly in mainland China and Taiwan, has generated strategic concerns in the West. More than 60% of the world's printed circuit boards are produced in this region, creating a dependence that Western governments consider unacceptable. This reality has triggered massive investment programs to develop local production capacity, with the United States and Europe committing tens of billions of dollars in incentives. The United States has launched initiatives like the CHIPS Act, which includes billions in subsidies for semiconductor manufacturing and related technologies, including advanced printed circuit boards. The goal is not just economic, it's strategic, to ensure that technologies critical for defense, infrastructure, and economy don't depend on vulnerable supply chains. This is a long-term bet that's reconfiguring global industrial geography. Europe is following a similar path with investment programs seeking to double or triple its advanced electronics production capacity. The European Union has identified printed circuit boards as a critical technology and is channeling billions of euros in subsidies, preferential loans, and tax incentives to attract manufacturers. The goal is to reduce dependence on Asia and create a more resilient and controllable supply chain. This geopolitical competition is creating opportunities but also tensions. Countries that traditionally dominated production see these moves as threats to their economic position. The response has been accelerated investment in automation, research and development, and capacity expansion. The result is a global race where billions of dollars are being invested simultaneously in multiple regions, driving innovation, but also creating the risk of future overcapacity. This is the new reality of an industry that went from being invisible to being strategically critical. Innovation in the printed circuit board industry is not incremental, it's revolutionary. Billions of dollars are invested annually in research and development, driving advances that enable the next generation of electronic devices. This constant innovation is what maintains market growth and justifies premium margins in advanced segments. Miniaturization continues to be a critical innovation front. Copper traces on advanced boards now measure less than 50 microns wide, and the industry is pushing toward 30 microns or less. Each reduction in trace width allows greater circuit density, which means more functionality in the same space. This capability is critical for increasingly thin smartphones, miniaturized wearables, and implantable medical devices. The technology to achieve these microscopic geometries requires equipment that costs millions of dollars and extremely sophisticated quality control processes. Advanced materials are opening new possibilities. Flexible and rigid flexboards allow designs that would be impossible with traditional rigid boards. Specialized high-frequency materials allow boards to operate in the gigahertz ranges necessary for advanced communications. Ceramic substrates allow operation at extreme temperatures. Each of these specialized materials creates market niches with margins significantly higher than standard boards. The integration of components directly into boards is blurring the line between the board and the circuit. Technologies like embedded components and silicon interposers allow integration densities that were impossible a decade ago. These techniques are critical for high-performance processors and artificial intelligence systems that require massive bandwidth between components. The development of these technologies represents investments of hundreds of millions of dollars, but the potential return is measured in billions. Sustainability is becoming an unexpected innovation driver. With millions of tons of printed circuit boards being discarded annually, pressure to develop recyclable materials and less polluting processes is growing. Companies that manage to master sustainable manufacturing techniques without sacrificing performance will capture not only economic value, but also competitive advantage in increasingly environmentally conscious markets. This is a frontier where technological innovation and environmental responsibility meet, creating opportunities for visionary entrepreneurs. The $95 billion market we've explored is not a final destination. It's a stage in a growth trajectory that seems to have no visible limit. Every emerging technological trend, from quantum computing to biotechnology, will require more advanced, more complex, and more valuable printed circuit boards. Quantum computing, although still in early stages, will require printed circuit boards with unprecedented capabilities. Control systems for qubits operate at temperatures near absolute zero and require extreme electromagnetic isolation. The boards that connect these systems to the outside world represent engineering challenges that are just beginning to be understood. This niche, although small in volume, could generate billions in value due to extreme complexity and premium prices. The integration of electronics with biology is creating completely new applications. Biocompatible printed circuit boards for brain implants, ingestible sensors, and advanced prosthetics represent the frontier between technology and medicine. These devices require not only extreme miniaturization, but also materials that can coexist with human tissue for decades. The implantable medical device market is projected at tens of billions of dollars, and specialized boards are critical, high-value components. Commercial space exploration is opening completely new markets. Every satellite, every probe, every space station requires printed circuit boards designed to operate in conditions that would destroy terrestrial components. With private companies launching constellations of thousands of satellites and plans for lunar bases and Martian missions, demand for space-grade boards is growing exponentially. This is a market where cost is not the limiting factor, technical capability is. We've taken a journey from invisibility to understanding the true economic power of printed circuit boards. $95 billion annually, billions of devices, entire industries dependent on these structures of copper and fiberglass. What began as a mundane technology has been revealed as the backbone of modern civilization, and as technology continues to advance, the value and importance of this invisible industry will only grow. The future of the global economy is literally printed in copper circuits, and that future has already begun.